Let's go back to the beginnings of artificial intelligence. Chess needs no introduction, but it is also closely tied to the birth of artificial intelligence. The Deep Blue project started in the 1980s at Carnegie Mellon University, initially named Chip Test, later renamed Deep Thought. IBM took an interest in the project and incorporated it into its research activities, transforming it into Deep Blue. The IBM Deep Blue computer was developed to defeat then-current chess champions and became famously known as a historical turning point in the field of artificial intelligence with its victory over world chess champion Garry Kasparov. However, the challenge proved more difficult than it seemed, as in the first match with Kasparov in 1996. Despite winning one game, the computer ultimately lost with a score of 2-4. The creators of Deep Blue didn't give up easily and made significant improvements, enabling the computer to predict 200 million positions per second. In 1997, this led to a victory of 3.5-2.5 over Kasparov. Despite Kasparov's desire for a rematch, it did not happen due to Deep Blue being retired from further use, with Kasparov famously referring to the computer's capability as intelligent as your alarm clock. Nonetheless, Deep Blue's victory over Kasparov not only went down in history as a significant technological achievement, but also marked a new era in artificial intelligence research, showing that computers can compete with and even surpass humans in certain specific, highly intellectualized tasks. However, the connection between artificial intelligence and chess does not end there. Things get even more interesting now, as while Deep Blue was able to predict 200 million positions per second and had access to a database containing all games played by chess grandmasters, all possible 5-piece endgames, and many 6-piece endings, its capabilities are nothing compared to the program AlphaZero, created by DeepMind, utilizing artificial intelligence. Surprisingly, it could predict only 70,000 positions per second and did not have access to any game database. The program literally started learning from scratch without any prior knowledge of strategy or tactics, except for the rules of the game. So how did it completely dominate chess, as well as other chess programs created for this purpose? Its success is attributed primarily to its unique approach to learning chess. Achieving the efficiency of playing millions of games per minute against itself, it gradually discovered strategy and optimal moves for each situation on the board, using deep neural networks and reinforcement learning. Betting with people on how long it would take AlphaZero to defeat the then-dominant chess program Stockfish, considered stronger than any chess grandmaster, could have been quite profitable. The surprise would likely have been greater than the bitterness of a lost bet. This program reached such a high level after only 4 hours of training by itself. It surpassed all existing chess systems at the time. AlphaZero not only learned to play chess at a grandmaster level, but also developed its own unconventional style of play, characterized by new strategies and unusual material sacrifices that were not previously known in traditional chess databases. This achievement was recognized as a breakthrough in the field of artificial intelligence, as it showed that machines could achieve and exceed human expertise without direct programming or teaching by humans. AlphaZero also illustrated the potential of machine learning and reinforcement learning for autonomously discovering knowledge and skills. Stepping away from AI for a moment, I also encourage delving into the history of one of the most legendary duels between human chess players, waging a war of minds on the board. This highlights the immense challenge faced by creators attempting to create an entity that could defeat the greatest geniuses of our species. Is this the end of artificial intelligence's engagement with board games? Hopefully to the delight of readers, not yet. Let's turn our attention to the Asian game of Go, which is lesser known in Europe but is gaining increasing popularity worldwide. Primarily, the game of Go, due to its immense complexity and the number of possible moves, was long considered unattainable for computers, especially in terms of defeating the best players. The story of an AI defeating a Go master is a fascinating moment in AI development, occurring in recent years. Let's delve deeper into this story. A key moment in this narrative was the emergence of AlphaGo, developed by DeepMind, a company belonging to Alphabet Inc. In October 2015, AlphaGo first drew attention by defeating the European Go champion Fan Hui 5-0 in a private match. In March 2016, AlphaGo faced one of the world's top Go players, Lee Sedol, in a historic match. The match consisted of 5 games and was broadcast live worldwide. AlphaGo won 4-1, a feat considered a groundbreaking achievement in artificial intelligence. Many moves, especially the famous move 37 in the second game, were assessed as innovative and non-human, demonstrating that AI can not only compete, but also creatively contribute to the development of the game. In May 2017, AlphaGo took on the world champion from China, KJA, during the AI Future of Go Summit in Wuzhen, China. AlphaGo won the series 3.0, affirming its dominance in the game. However, that was not the end. With the development of the previously mentioned AlphaZero, which also, through several hours of playing against itself, managed to defeat its younger sibling AlphaGo, raising the bar even higher. Defeating Go masters with AI was not only a demonstration of the capabilities of machine learning, but also a moment that led many to reflect on the potential future possibilities of artificial intelligence and its impact on various aspects of life. AlphaGo and its successors showed that machines could discover knowledge and strategies surpassing human experience and intuition in specific domains. I especially encourage watching the story of AlphaGo. It is a fascinating tale that showcases a real battle of the human mind against AI and the transformation many people underwent, who simply did not believe that defeating the best Go player was possible for artificial intelligence. Not only did it happen, but it also made everyone realize how little they knew about the game. Moving away from AI's involvement in board games, let's trace the history of the popular language model, ChatGPT. In 2015, OpenAI was founded by Sam Altman, Elon Musk, Greg Brockman, Ilya Sutskever, Wojciech Zaremba, and John Schulman. The organization's goal was to develop and promote artificial intelligence for the benefit of all humanity. Since its inception, the leadership of the project has undergone several changes, one of the more significant being the departure of Elon Musk, who is currently also developing his own AI technology. Between 2015 and 2017, OpenAI initially focused on various research projects, exploring aspects of machine learning, reinforcement learning, and robotics. A pivotal year was 2017 at the NeurIPS conference, one of the most important conferences on machine learning and artificial intelligence. A team of researchers led by Ashish Vaswani presented the paper, "Attention is All You Need," initiating one of the most significant shifts in AI development, particularly in the field of natural language processing, NLP. This was made possible by creating an innovative neural network architecture that changed the approach to sequence processing, especially in NLP. Unlike its predecessors, such as recurrent neural networks, RNNs, this transformer model was not subject to sequential data processing, allowing it to process entire data sequences simultaneously. This significantly improved processing speed, greatly reducing the time needed to train the model while increasing its efficiency, especially with large databases. The traditional transformer architecture consists of 2 main parts: the encoder, which processes the input sequence, and the decoder, which generates the output sequence. In applications like machine translation, encoders and decoders work together to process and generate text. Both the encoder and decoder consist of a series of identical blocks that include attention layers and fully connected neural network layers. The transformer's central element is the IA attention mechanism, allowing models to focus on different parts of the data sequence while processing information. This enables the model to better understand context and dependencies in the data. The transformer architecture quickly became the foundation for new models in NLP, including groundbreaking systems like BERT, bidirectional encoder representations from transformers, developed by Google, and GPT, Generative Pre-trained Transformer, created by OpenAI. In summary, the presentation of this paper was a significant moment that brought to the scientific community's attention new possibilities in language processing and machine learning. Its impact extended far beyond the conference itself, becoming a milestone in AI development. In 2018, the first iteration of GPT was presented. Despite its innovation, it was only a prelude to what was soon to come. The year 2019 saw the field of the next version, GPT-2, which gained much attention for its ability to generate text. However, due to ethical concerns about advanced AI technologies and fears of misuse, OpenAI initially withheld the full release of the model. In 2020, OpenAI introduced GPT-3 with parameters of 175 billion, making it one of the largest language models. It also saw full commercialization, enabling companies and developers to create applications based on it. Further development continued with the subsequent versions, GPT 3.5 and GPT 4, which became incredibly popular and are now a permanent part of the tool arsenal used daily by people worldwide. GPT 3.5 introduced improvements in understanding and generating more complex and contextual responses. Focus was placed on improving the ability to conduct coherent and sensible conversations, better context retention, and more advanced natural language processing. GPT-4 naturally was an even more advanced model, enriched with capabilities like generating graphics using DALL-E and reading content from images inserted in chats. It's also worth delving into the history of DALL-E, also created by OpenAI, which was launched in early 2021. It was the first model to use GPT-3 techniques to generate images from textual descriptions. The next update, DALL-E 2, introduced in 2022, featured significantly improved image quality, better and more realistic details from textual instructions, and allowed users to modify existing images. The subsequent iteration, DALL-E 3, was even more efficient, faster, and generated higher resolution images. Algorithms were refined compared to their predecessors to better handle more complex and detailed queries. The number of parameters in language models like GPT-3, GPT 3.5, and GPT-4 is a key indicator of their complexity and potential capabilities. In the case of the GPT-3 model, the number of parameters was 1.5 billion. For versions 3.5 and 4, such information is not available, but it is highly probable that this number significantly exceeds 175 billion, allowing for even greater complexity and language understanding and generation capabilities. However, increasing the number of parameters also presents more significant technical challenges, such as computational needs and performance optimization. In discussing the generation of images through AI, it is pertinent to mention other examples as well. The first model is the Bing Image Creator, a tool developed by Microsoft for generating images, which forms part of the company's broader strategy in artificial intelligence and machine learning. Microsoft's endeavors in artificial intelligence date back many years, encompassing the development of technologies such as Cortana, their voice assistant, and numerous projects related to machine learning and natural language processing. Microsoft, in developing its Bing search engine, focused on integrating advanced AI technologies to enhance user experiences in search and content browsing. This led to experiments with various forms of AI, including image generation. The development of image generation tools by other companies like OpenAI's DALL-E likely motivated Microsoft to accelerate its own efforts in this area. With experience in AI and vast resources, Microsoft was able to swiftly respond to these trends. Ultimately, Bing Image Creator was announced as a tool that allows users to generate images based on text descriptions. Its integration with Bing facilitated easy access to the tool via the search engine, offering a unique combination of image search and generation. Microsoft also developed its own artificial intelligence technology similar to OpenAI's ChatGPT, known as Turing Natural Language Generation, TNLG, announced in February 2020. TNLG, one of Microsoft's largest language models, was named in honor of Alan Turing, a pioneer in computer science. At the time of announcement, TNLG was one of the largest language models, containing an impressive 17 billion parameters, enabling more complex and coherent text generation. The language model, developed by Microsoft, commercially available as Azure OpenAI Service, provides access to advanced language models, including OpenAI's, through the Microsoft Azure Cloud Platform. This platform enables companies and developers to integrate sophisticated AI features. At this juncture, many readers may notice that Microsoft also provides access to GPT and wonder about the relationship between these two entities. The explanation is straightforward. The development and training of large AI models, such as GPT-3, require significant computational power and infrastructure. OpenAI needed a partner capable of providing the necessary resources. In 2019, Microsoft announced a $1 billion investment in OpenAI. This investment was a strategic move to support research in artificial intelligence and the development of AI technologies. As part of the collaboration, OpenAI decided to use Microsoft Azure's cloud platform for training its AI models. Azure offered not only the required computational power, but also advanced tools and services crucial for AI development. This alliance was primarily a response to the growing global interest in AI and the need for more advanced and scalable solutions in this area. Microsoft, as a global technology giant, had to keep up with the competition and could not afford to slow down. This collaboration is an example of how large technology corporations can work with innovative AI companies to accelerate the development and deployment of new technologies. This partnership also indicates the direction future initiatives and partnerships in artificial intelligence might take, where one entity, possessing the right technology and know-how, lacks sufficient resources and thus collaborates with another that can provide them. Another noteworthy project generating images based on text commands is the Midjourney project, created by Midjourney, Inc. The images generated by this model are considered public domain and are not subject to copyright protection. It was quickly adopted by various industries, including advertising and architecture, for its ability to rapidly generate original content and visualizations. However, the tool has faced criticism from some artists who believe it utilizes their original creative works in its training set. Despite this, Midjourney has a DMCA policy for removing content at artists' requests. This is just the beginning of what we can expect in the near future. Currently, Adobe Inc. is developing a new feature for Adobe Photoshop called Generative Fill, supported by Adobe Firefly. This feature allows users to add and remove content from images non-destructively using simple text commands. Generative Fill enables quick and easy creation of realistic results, saving users time in creating photorealistic or surrealistic ideas. It represents an exciting step in integrating AI with creative tools. Of course, this is only a glimpse of the AI tools available for image generation. Tools like Leonardo AI and Google's Deep Dream have also gained significant popularity. Google, as one of the leaders in innovation, has a long history of research and development in AI, and their contributions include a wide range of technologies, from machine learning algorithms to the development of advanced artificial intelligence systems. Google began focusing on AI relatively early. One of the first significant steps was the acquisition of DeepMind in 2014. Another key element in Google's AI development is the Google Brain project, started in 2011. Google Brain focuses on deep learning, a subfield of machine learning inspired by the human brain's workings. Google Brain created TensorFlow, an open-source machine learning platform that has become the industry standard for AI researchers and developers. Google also develops AI technologies in more consumer-focused applications, such as Google Assistant, which uses advanced speech recognition algorithms and natural language processing to enable user interactions with devices through voice. This demonstrates how AI technologies are integrated into everyday products. In recent years, Google has continued to innovate in the AI field, introducing new initiatives like Google Gemini and Bard. Gemini is the internal code name for Google's efforts in generative AI models, aimed at creating more advanced and understandable user interactions by generating text, images, and other forms of content. Bard, announced in early 2023, is Google's direct response to the popularity of OpenAI's ChatGPT. It aims to provide users with a tool for generating content that can aid in education, creation, and solving everyday problems, utilizing advanced AI technologies, including machine learning techniques and natural language processing. The history of artificial intelligence development is rich with numerous groundbreaking moments, creating an incredible narrative about how our species had to mature to reach the point where we currently stand.